The Nano World.
Good day, sir. We are Group 7. Our topic is all about the nanoworld.
I am Judith Ladaga. I'm Rubelin Roses.
I'm Lorenzo Ihido.
Good day, sir. We are Group 7, and today we discuss about the nanoworld. Nanoworld is the global market leader for tips for scanning probe microscopy, or SPM, and atomic force microscopy, or AFM. Nano means is an exceedingly small amount of measurement. A nano is equal to 1 million of millimeter. It is impossible to see it with a naked eye or some simple magnifier. The nanoscale is used in atomic measurements to determine the sizes of matter particles. So nano is kanang very small kayo sa diya nga bisan o kanang na pag tanaw sa mata di siya makita kinahanglan pa sa diya og kanang other instrument nga maka-identify ni diya. So many scientific researchers have developed new technological tools that greatly improve different aspects in our lives. The use of nanoscale is one important interdisciplinary area generated by advancement in science and technology. Scientists and engineers were able to build materials with innovative properties as they manipulated nanomaterials. Indeed, research and application of knowledge on nanomaterials will continue to bring widespread application in various areas of society, especially healthcare, environment, energy, food, water, and agriculture.
So, nanotechnology refers to the science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers, according to National Nanotechnology Initiatives 2017. Nanoscience and nanotechnology employs the study and application of exceptionally small things in other areas of science, including material science, engineering, physics, biology, and chemistry, according to National Nanotechnology Initiative 2017. So nanotechnology plays a key role in communication, engineering, and has a wide array of applications. The use of nanotechnology can affect the telecommunications industry in numerous ways. This paper provides an insight into some of the latest breakthroughs in nanotechnology. So, nanotechnology ay gumaganap ito na isang mahalagang papel sa engineering ng komunikasyon at may malawak na hanay ng mga aplikasyon. Ang paggamit ng nanotechnology ito ay makakaapekto sa industriya ng telekomunikasyon sa maraming paraan. Ang papel na ito ay nagbibigay na insight sa ilang mga pinakamabagong pambihirang tagumpay sa nanotechnology na kinabibilangan ng iba't ibang device tulad ng nanotransistors, papel na baterya, nanorobotics, nanosensors, wireless na teknolohiya, nano-communication, at mga network. Nakatuon din ito sa kung paano inaasahang mapapagana ng paggamit ng teknolohiyang ito ang paggawa ng mas maliit, mas mura at mas makapangyarihan ng mga elektronikong device na may pagtaas ng kahusayan.
The concept of nanotechnology and nanoscience started in December 29, 1959, when physicist Richard Feynman discussed a method in which science can direct and control individual atoms and molecules in stone. There's plenty of room at the bottom. During the American Physical Society meeting at the California Institute of Technology, the term nanotechnology was coined by Professor Norio Taniguchi a decade after the dawn of the use of ultra-precision machines. So, the, ter- the term nanotechnology, after the dawn of the use of ultra-precision machines, how small is a nanoscale? A nanometer is a billionth of a meter, or 10 to power to negative 9 of a meter. Manipulation of nanomaterials need an added understanding of their types and dimensions. The various types of nanomaterials are classified according to their individual shapes and sizes. They may be particles, tubes, wires, films, flakes, or shells that have one or more nanometer. Such dimension, one should be able to view and manipulate them so that we can take advantage of their exceptional characteristics. So, ang pag-work or operation sa nanomaterials, kinahanglan sa siya og kanang laon nga pag kanang kay working nga mag-tutok na siya or kana ba concentration sa pag kanang operate sa nanomaterials kay namas dyan lain nga particle bitaw sa different kanang different nanotypes of kanang different materials. So, nag-classify mo dyan according to their individual shape or sizes. So, kinahanglan din siya o kanang adapted nga kanang manipulation sa nanomaterials. How to view nanomaterials? Scientists use special types of microscope to view minute nanomaterials. During the early 1930s, scientists used electron microscope and field microscopes to look at the nanoscale. The scanning tunnel microscope and atomic force microscope are just among the modern and remarkable advancements in microscopy. There are three types of special microscope that the scientists use to view the nanomaterials. First are electron microscope. German engineers Ernst Ruska and Max Knoll built the first electron microscope during the 1930s. This type of microscope utilized a particle beam of electron to light up a specimen and develop a well-magnified image. So, this electron microscope, nagkuha sa dyan kanay, mag-utilize dyan sa particle na kanang na light, klaro, clear ang light, then mo produce dyan o clear na image sa then kuhaan ko sa dyan kanang the electron microscope produce higher and better resolution than older light microscope because they can magnify object up to 1,000,000 times, while sa other or sa older nga kanang microscope, which is the conventional light microscope, can magnify object up to 1,500 times only. So, pas siya kanang maadyo siya kaysa sa kanang older na types of microscope. So there are two types of general types of electron microscope, which is the scanning electron microscope or CEM and transmission electron microscope or TEM. The second types of microscope to view the nanomaterials are atomic force microscope or AFM. It was first developed by Gerd Binig of Calvin Kuwait and Christopher Herbert in 1986. It makes use of a mechanical probe that gathers information from the surface of a material. So, they use mechanical probe para nga makagather sila of information gikan sa ibabaw sa materials na ilang experiment or ilang tanawon. Then, the third and last type of microscope they use are scanning tunneling microscope. This special type of microscope enables scientists to view and manipulate nanoparticles, atoms, and small molecules. In 1986, Gerd Binig and Heinrich Rohrer won the Nobel Prize in Physics because of this invention. So, this third one is para sa director ba murag high siya nga maka-manipulate or view na din siya sa kanang mga nanoparticles, atom, and small molecules in a kanang dali ra nga paraan.
Nano-manufacturing. It refers to scaled-up, reliable, and cost-effective manufacturing of nanoscale materials, structures, devices, and systems. So, sa nano-manufacturing is kuan ang nano-manufacturing is pinakagamit or maasal or reliable sa manufactured sa nanoscale materials sa mga devices or sa system, ang kaning nano manufacturing is pinakagamit sa kuan paghimo sa mga materials nga nanoscale like devices and system. So, it also involves research, improvement, and incorporation of processes for the construction of materials. So, sa pag-manufacture sa mga nanoscale materials like devices and system, so ila pa ning i-studyhan or ila pa ning research daan or kung saan nila pa-improve sa usa ka materials sa usa ka mga device. So ila sang i-studyhan daan usa nila construct ila bang gihimo usa nila gihimo ang usa ka material, so ila pang i-studyhan daan para inigbuhat nila is kanang kuana kanang hapsay inig kuana kanang nindot na inig mabuhat nila inibuhat nila sa usa ka device, inig-repair nila sa usa ka device, nindot na ang kanang resulta. So, therefore, nano-manufacturing leads the development of new products and improved materials. So, ang nano-manufacturing is kuan, ang pag-develop sa usa ka product ug sa materials. So, kita like sa una is kanang ang mga cosmetic nila sa una is kanang man-made ra kanay sila rin naghimo or sa ilang pangkuan sa mga lawas. So, ibalik sa una, agkuan po, din na yung mga gamit sa pangbay is ilan pong hindi mo bidya, and then agkaroon kay kuan naman, kanang like, pura nagnakuan na ta sa technology, so mga, nagsalig kita sa mga technology, di ba, at hintay karon nga mga gamit is kanang laptop, kanang kuan na, sa una is kanang agato, bidya kay Nokia ra, di ka adyo ta makakuan ba kanang makabuhat sa atong mga report nga na di na to ka adyo makuan. There are two fundamental approaches to nano manufacturing, either bottom up or top down fabrication. So number one is bottom up fabrication. It manufactures product by building them up from atomic and molecular scales component. So ang bottom up fabrication is kini mismo ang naghimo sa kanang kuan mga product nga gagamit ang kuan atomic ug molecular scales na mga bahagi. So scientists and engineer are still in search for effective ways of putting up to organized structure. So ang mga scientists ug engineer is kuan gyapon nga nangita gyapon sila og unsay ng mga kuan mga epektibong pamaraan o kung saan nila paghimo sa usa ka materials or sa mga kuan nanoscale like devices and system. So ito ay matagal na oras or kini ang sa bottom up ay ang pinakadugay nga sa paghimo sa materials mo ni ang pinakadugay nga kuan process para mahimo ang kanang new product. The number two, top-down fabrication. It trims down large pieces of materials and discards excess raw materials. So, pinuputol nito ang malaking piraso ng mga materials sa nanoscales. Ang prosesong ito ay nangangailangan ng mas malaking halaga ng mga materials at itinatapon ang labis na mga materials. So, mula sa salitang top-down, ginagawang nanomaterials ang malaking materials. So, ang ditay sa bottom-up fabrication is kuan man ang sila mahinghing naghimo sa usa ka product. So, ang top-down is kuan murag sila provide sa unsay mga kinahanglan sa paghimo sa product sa bottom up, ibali ang karing top down mo ay nag-provide sa mga product para ma-invento ang usa ka materials or mabago or kanang makuan siya matawag na kuan na new materials. Number 2, top down fabrication. It trims down large pieces of materials and discards excess raw materials. So, ang top down fabrication is kanang kuan proseso. Ito ay isang proseso ng nangailangan ng mas malaking halaga ng mga materials at itinapon ng ang labis na hilaw na materials. So, ibali ang galing top-down fabrication is kuan. Ang mga materials nga, mga dagko is ilang gipagamay like katong kanay kaya at sa laptop, di ba, pwede man nato masudlan og mga mga ato mga report, pwede ta ato mag-encode, maghimo og mga Microsoft kanang Excel or Word or kanang publisher din. Pwede man pud so ilang gi pa kanang ngay ilang gi pa ilang gi murag gi gamay so ilang gi himong ang mulas ang top down ginagawang nanomaterials ang malaking materials so ang dagko nga mga materials gihimong gagmay so ibalik sa katong kuan lagi computer or sa laptop, di ba? Pwede man ta makahimo atong mga documents or mga files. So, sa cellphone media po, is kanang makahimo media punta kay nang po kuan WPS mo to nga ang top-down fabrication is sa dagko nga mga materials is gihimong gagmay para mas dali nila makuan mahimo ang usa ka product. There are new approaches to the assembly of nanomaterials based from the application of principles in top-down and bottom-up fabrication. So, this include, number one is deep pin lithography. So, deep pin lithography, it is a method in which the tip of an atomic force microscope is dipped into a chemical fluid and then utilized to write on a surface like an old-fashioned ink pen onto paper. So, ang deep pin lithography is mura na ibalay ka ng ibal sa usa ka materials kanang pindil pen. Diba? Ato nang nanay ink yan na. So, ang katong ink mo toy kuan kanang kibalay kuan to kanay gamay bija kanang liquid bija na fluid. So, kanang ang usa ka ang pindil pen so mo to ang usa ka butang na kuan sa nanong manufacturing nga pwede na ito masuwat sa like nga sa Manila paper. So, kani ang usa ka katong pindil pen mo to usa ka kanang materials nga nakuan sa deep pen lithography. Self-assembly. It depicts an approach wherein a set of components join together to mold an organized structure in the absence of an outside direction. So, example din is kanang maghimutag sa ka computer. So, if naikuha nga material sa pag-imo na to sa ka computer, so di siya ta maka-develop og kanang computer. So, kinahanglan nga kuan ta maka set of components join together ta sa paghimo sa usa ka kanang sa computer or sa ka mga product para ma-develop or kanay makahimo ta og kanang bag-o nga computer or kanang buo ta og kanang kanang computer or mga devices nga kanang dapat nga kumpleto ang mga materials para kanang mahimo jud og tarong. So, chemical vapor deposition. It is a procedure wherein a chemical acts in response to from very pure high-performance film. Chemical vapor deposition. It is a procedure wherein a chemical acts in response to from very pure high-performance film. So, ang chemical vapor deposition is muni ilang gigamit or muni ilang paraan para inig mag films mo. So, kani ang gamiton para kanay naamoy tan-awon or namoy himuon nga films is kanang tin-aw or kanang pure kanang tan-aw na to is kanang klaro ba kanang usa ka kanang film or usa ka kanang salida mo nang ang chemical vapor is muni lang gigamit para kanang pagkuan sa film is kanang tin-aw or kanang nindot tan-awon inig naay mananaw ang mga tao or magkuan sa like kanang mga movie. So, kini lang gigamit nga kanang procedure para kanang tinaw ang films ba or kanang nano-imprint lithography. It is a method of generating nanoscales attribute by stamping or printing in them into a surface. So, ang nano-imprint lithography is kanang usa ka paraan sa nanoscales materials sa paghimo sa kanang by stamping or printing sa mga kanang mga sa mga kanang papel kanang natay pang stamp. So money nano-imprint lithography money ang gamiton para pagtatak sa mga papel nga stampingan. Molecular beam epitaxy. So it is one manner from depositing extremely controlled thin film. So ang molecular beam epitaxy is kanang ibalay mo ni ang gamiton para kana inig mag-edit tag usa ka kanang video or film is kanang magagmay ba mura magmamubo na kibali kuan ang usa ka ang taas nga movie film is mura nag ilang nipis ilang gipagagmay so mo ilang gigamit molecular beam epitaxy sa pag-edit sa mga video nga dagko so gipagamay na nila. Roll-to-roll processing. It is a high-volume practice for constructing nanoscale devices on a roll of ultra-thin plastic or metal. So, a roll-to-roll processing is muna ang gigamit sa paghimo sa nanoscale device sa like sa mga plastic na mga materials or of metal. So, atomic layer epitaxy. It is a means for laying down one atom thick layers on a surface.
Features of nanoscale. So, nanotechnology nag-involve siya ang operating at a very small dimension and nag-allow siya sa scientists to make use of the exceptional optical, chemical, physical, mechanical, and biological qualities of materials of the small scale. So there are three following distinct features of nanoscales. First, the scale at which much biology occurs. So, various activities of the cell take place at the nanoscale. The deoxyribonucleic acid or DNA serves as the genetic material of the cell and is only about 2 nanometers in diameter. Furthermore, the hemoglobin that transports oxygen to the tissues throughout the body is 5.5 nanometers in diameter. Example of this is the biobarcode assay, which is a fairly inexpensive approach for identification of specific disease markers in the blood despite their small number in a particular specimen. The second is the scale at which quantum effects dominate properties of materials. So, particles with dimension of 1 to 100 nanometers have properties that are significantly discrete from particles of higher dimension. So, quantum effects direct behavior and properties of particles. In this size scale, the properties of molecule materials are highly dependent on their size. So, among the essential of these properties of nanoscale that change as a function of size include chemical reactivity, fluorescence, magnetic permeability, melting point, and electrical conductivity. One example is this nanoscale gold, which is not only the yellow-colored element we are used to seeing, but it can also appear green or purple. Gold's electrons display restricted in motion in the nanoscale. Practically, nanoscale gold particles selectively build up in tumors where they permit both precise imaging and targeted practically, nanoscale gold particles selectively build up in tumors where they permit both precise imaging and targeted laser destruction of the tumor while avoiding damage on healthy cells. So, the last one is nanoscale materials have far larger surface areas than similar masses of larger scale areas. So, ang nanoscale materials naa siya larger surface areas than similar masses of larger scale materials because as we increase the surface area per mass of a particular material, a greater amount of the material comes in contact with another materials and it can affect its reactivity. There are government funding for nanotechnology in different countries according to Dairy 2005. So the first government funding is U.S. National Nanotechnology Initiative. U.S. National Nanotechnology Initiative is the best known and most funded program sa National Technology Initiative of the United States. The second is European Commission. The third is Japan Nanotechnology Research Institute under the National Institute for Advanced Industrial Science and Technology, or AS. Fourth is Taiwan National Science and Technology. Fifth, India Nanotechnology Research and Education Foundation. Sixth, China National Center for Nanoscience and Technology. Seven, Israel National Nanotechnology Initiative. Eight, Australian Institute for Nanotechnology. 9. Canada Institute for National Nanotechnology, or NINT. South Korea Korean National Nanotechnology Initiative. Thailand National Nanotechnology Center, or Nanotech. Malaysia National Nanotechnology Initiatives, or NNI. So, there are possible applications of nanotechnology in the Philippines according to DARE 2005. First is ICT, or semiconductors. Second, health and medicine. Third is energy. Fourth is food and agriculture. Fifth is environment. There are possible applications of nanotechnology in the Philippines according to DARE 2005. First is ICT, or semiconductors, health and medicine, energy, food and agriculture, and environment. So, there are possible nanotech roadmap for the Philippines founded by PCAS, PRD, and DOS, or Philippine Council for Advanced Science and Technology Research and Development, a Department of Science and Technology. So, nanotech roadmap means productive nanosystem charts a path beginning with current nanotechnology's capability to advance system. The roadmap is first attempt to lay out a step-by-step course of development that must take place to move from one stage to another with milestone for achieving each step. First is ICT and semiconductors, health and biomedical, energy, environment, agriculture and food, health and environmental risk, nanometrology, education, and public awareness.
Benefits and concern of using nanotechnology. Nanotechnology has various applications in different sectors of the society and environment. So Salamanca Buentelio proposed an initiative called Addressing Global Challenges Using Nanotechnology. So si Salamanca Buentelio ming address siya o kanang na using nanotechnology to address bitaw some global challenges, example kanang mga mga about sa kanang overcoming challenges about health, about kanang kanang employment or nga na kasi health hingga na mga daghang nanotechnology to decrease kanang daghang mga tao nga lala ang sakit, so makatabang ang nanotechnology para nga ang risk sa kanang mga health diseases ma-decrease siya. So there are some benefits po of kanang concern nga. First is nanotechnology is not a single technology. It may become pervasive. So dito siya ang nanotechnology, dito siya single technology. Kung pa siya laganap pa siya na technology for kanang in terms of kanang medical, kanang technology for kanang mga cellphone or nga na or kanang for employment or kanang agricultural technology. So laganap din ang pagani sa nanotechnology dire nga sa single na kanang department or kanang nga lugar or kanang nga na. So nanotechnology seeks to develop new materials with specific properties. So, ang usapod ka ng technology, depende sa iyang kuan, depende sa iyang department or sa iyang nga klase, napos dyan specific nga kanang properties. Dili dyan nga kinahali sa medical ug sa kanang mga nanotechnologies gamiton sa farming, di man sila pareho kay kuan man sila kanang lain man sila og gamit. So, di sila pareho og properties. Then sa the nanotechnology may introduce new efficiencies and paradigms which may make some natural resources and current practices uncompetitive or absolute. So, na may kanang ang nanotechnology pwede mo sa job ka naman dali ra bitaw, dali ra nato ang gamit, dali ra nato mapan kay mga gamit sa bahay, panglimpyo, mga kanang map kitahan ng electric map ron kanang sige nga vacuum mena so nas ja so ang kanang nay kuha na bitaw kita mga tao mga natural resources na to sa unang mga bunot or mga nga na di na nato magamit kay nana na sa mga nanotechnology so kuha na di na to sa ingan nga useful ka dito nato sa kanang karon kay nagamit naman tao mga nanotechnology. Then, it may be complicated to detect its presence unless one has the specialist tools of nanotechnology. So, tungkol sa kadaghanan ng technology, napay di na mo yung bawaan kung unsa na klase unless kung usa ka specialist na about ingana nga technology. Then, another benefits and concern of the application of nanotechnology in different areas. There are different areas in terms of environment, health, and economy. Then, in terms of environment, what are the possible benefits? So, this is the possible benefits: improved detection and removal of contaminants, development of benign industrial process and raw materials. Then, improved detection and removal of contaminants. So, daghan ng contaminated bitaw ng mga areas bitaw sa ating environment. So, makatabang ang nanotechnology para makakuha siya, ma-detect siya nga, kay napita, kani siya, kanang contaminate, na may mga, kuan na, ba yung detect lang sa mga, grabe na bag-oil, din napita, or nga na, so, makadawag na sa environment, so, makatabang siya para ma-detect. Then, development of benign industrial process, mga goods bitaw nga industrial process na makatabang sa atong environment tungod na sa nanotechnology. Then, kung naay karang benefits, napoy concern. So, ang concern natin sa environment, high reactivity and toxicity. Kung di na pa rin napoy uban na makaproduce with og more on toxicity sa atong environment, makadaot din siya pa sa atong environment. Then, pervasive distribution in the environment. Laganap na ang nanotechnology sa environment. So, murag sadya ka na magbad pa sadya sa atong environment kay murag sadya laganap ka Judith. No non-specific EPA regulation. Di nilapita. Usapon din sa concern pod sa nanotechnology sa environment kay bas the regulation nga kanang jud nga specific nga nag-regulate nga kana sadya mauna makadaot na sa environment nga na o ba specific nga di na pwede buhaton di na pwede nga na kay so mo ni mga concern sa nanotechnology in terms of environment.
Another benefits and concern of the application of nanotechnology is different areas is health. So, the possible benefits of health is improved medicine. So, ang mga improved medicine karon nga na involved is kanang mga machine. So, mga incubator, mga gamit sa pag-opera sa mga mga cancer or mga kanang sakit-sakit is nanabi dyan mga bag-o ron. So, ang kanang sa health is mas ipa-improve pa ang mga medicine nga mga gamiton sa pag-opera or pagtambaw sa kanang sa mismong sakit. So, sa health is na may possible benefit, so na po ay concern. So, sa concern sa health is ability to cross cells, membranes, and translocate in the body. So, ang health is na po'y concern. So, sa paggamit na to sa nanotechnology is it is ability to cross cell membranes and translocate in the body. So, ang kuan yan na ingab jay i-inject sa mga pasyente is ngab jay possible nga na po'y nanay makadaot sa kanang nay mukana sa atong lawas pa then madaot atong lawas so na po'y positive nga kanang inig na kuan ta may injectionan sa kanang mga nang kuan para sa atong lawas natay i-inject so nang po'y possible nga mukana sa atong lawas nga makapa kuan kun hinuon nato makapaadyo so mo ni ang concern sa health sa kuan nanotechnology so sa mga benefits.
The last one, benefits and concerns the application of nanotechnology in different areas is economy. So there are possible benefits of nanotechnology in economy. First is better product and new job. Better product and new job, makatabang ni siya sa economy, na maka-create og better product o maka-kuan ko tawag new job. Example ka ng online business, through online and magamit mo sa technology. Then na ako sir, concern sa ating economy sa nanotechnology is this redistribution of wealth. Murag di na fair ang pagkuhan sa kayamanan kanang murag pag-distribute kay ang uban murag og kanang saktong paagi ang uban pod na gibuhat pod niya di sakto. Then potential cost of cleanups and healthcare and accessibility to all income of level.